Hello, class. Welcome to MSc 3371 Management Science. My name is Priscilla Fiala, and I'm going to be your professor for this term. Last term, I decided to record videos to show the problems and answer questions, and that was actually welcome by many students. And so I decided to keep doing that. I can promise that I'll be recording videos for every problem that I assign, but I will record them as time permits. For week one, you have been asked to read chapters 1, chapter 15, and chapter 16. Note that your book only goes up to chapter 15. However, I did post in class including on your discussion today and before that on the notes as well. I also posted the chapter 16 in the PDF format that talks about Markov process, and I ask you to read that. I have posted videos as well. Here is the PDF. Okay, so if you can please read, we are going to really be focusing on chapter 15, but I do need you to look over chapter 1 and chapter 16 and how it relates to chapter 16 relates to chapter 15. Okay, so in case you're not sure how to get in class and access your book, I also posted a video under week one. And the way you should start is always by looking at announcements. Important announcements I posted here, and you also should get a notification via email that an announcement has been posted. To find the course outline, the common course outline is right here. Okay, for every class book, you go in course outline and book, and right here you have the book. Click on this link or on this link, any area here, as long as it turns into this little hand, and it's always gonna give you this message. You just put launch content and then it should open your book. If you do have any problems accessing the book, first of all, make sure it's not your computer that is blocking anything and preventing you to open the book. If it's any other kind of problems, feel free to send me an email and I will forward to the EAP department to assist you with that. Okay, so that's how I have got your book. I'm going to be closing the class now. I have posted also your discussions. Um, if you don't know how to post your homework, just click on week one assignments and it's going to tell you what is the homework. In order to, once you complete the homework, you click on the link here and it's going to tell you where is the due date, how many points are possible, and then you can either write a submission, which would not be possible because you're going to have several calculations. What you're going to do once you save to your computer, you browse your computer and then you're going to find what you need, and then you can just when you finish everything you can put me on you can put a note for me here and submit. Don't save. If you save it, I don't receive it. So make sure you submit by the deadline. Okay, so let me close here. We have chapter 1. Chapter 1, it address, let me go here. Chapter 1, contents. Here we go. So chapter 1 address mathematical models. The more closely the more the model represents the real situation, the more accurate the conclusions and predictions will be. So we must consider the cost and benefit in order to choose the appropriate model. That's usually right here: cost and volume models, revenue and volume models, profit and volume models, and the break-even analysis. The break-even analysis is a very popular model. You probably heard the term in your economic class, for example. If you do remember, the break-even analysis refers to the point in which the total cost and the total revenue are equal. You're not considering any net gain or a loss. You just trying to see where the total cost and total revenue are equal. And pretty much is the model analysis how many units or revenue is needed to cover the total cost. In the break-even analysis, we need to take into consideration, which I'm just saying here, but if you do go on the chapter itself, you're gonna find all these details. I'm just summarizing. uh, so the break-even analysis, it analyzes how many units or revenue is needed to cover the total costs. So we need to take into consideration fixed costs. For example, fixed cost is not really going to vary much. That's why it's called fixed. You're talking about salaries, for example. Salaries are going to be fixed for a while, unless you provide your give your employees a raise eventually. Then it also takes into consideration the variable costs. For example, material. How much material do we need? The price of material, for example, that would be a variable cost. It takes into consideration marginal cost. That is the cost added by producing one additional unity of a product or service. I'm sure you heard of marginal cost before. The marginal revenue, which is the additional revenue that will be generated by making and selling that product or that unit. And then lastly, you would be talking about contribution margin, which is the product price minus all the associated variable costs that I just mentioned. Okay. Um, Chapter one also talks about other models, and especially by when you set an objection function. That means the problem's objective. What is the problem objective? Are you gonna maximize profit or are you gonna minimize cost? There would be an objective function. However, in order to maximize profit or to minimize costs, for example, you would have to take into consideration the constraints. Constraints are limitations, those are restrictions. For example, if you are trying to produce something and you know that you only have 40 hours per week to complete that. So that would be a constraint. You cannot complete that or finish the product using more than 40 hours per week, or you do have to increase those hours, but then you're also gonna consider that you have to pay overtime, for example. Okay, so other things consider they're calling the uncontrollable inputs. That means it's not under control of the decision maker, um, like a production capacity. Just like I made the example right now, the hours per week, um, not necessarily is going to be under the control of the decision maker. If they give only 40 hours per week, not necessarily is going to be produce as many as he or she would like to produce. Um, One model that is presented in this chapter, and when you're trying to find something faster, this shouldn't be on chapter 2, but when you're trying to find something faster, for example, I'm going to talk about the stochastic model. Just do go to search right here and do I don't know if they call it the stochastic or they call it the probabilistic. Oh, both. Probabilistic. Okay, here you go. Um, so under uncontrollable inputs, they mentioned the probabilistic model or stochastic. Um, this model is a little more difficult to analyze since it involves uncertainty. So if any uncontrollable are uncertain and subject to variation, then they're going to be called stochastic or probabilistic model. For example, recession. That's something that um, you couldn't really include in your model, and it's definitely an uncertain or an uncontrollable input. And then also it goes into controllable inputs. I believe in this page right here. Yes. Um, which, if you think that uncontrollable is not under the control of the decision maker, then you say the controllable, that means they are under the control of the decision maker. For example, the number of tables to be produced. That's something that a manager can decide, can determine. Under the uncontrollable inputs, they also mention deterministic models. Uh, that means all uncontrollable inputs to the model, they're known. They cannot vary. So let's see what they say here. Can be either be known exactly or be uncertain, subject to variation. If uncontrollable inputs to a model are known and cannot variable, the model is referred to a deterministic model. Okay. Going back to the break-even analysis, the formula is actually very simple, which to calculate the break-even point, you're gonna have to do your fixed costs divided by your selling price minus your variable costs. We are not gonna be calculating that, but please go over the chapter. If nothing else, make sure you read the summary, you read the definitions, um, see which ones you have heard of it before. Okay, so that's for chapter 1. Chapter 16 is going to talk about the Markov process. I did summarize it for you under your weekly discussion, so please read that and watch the videos. The most important thing now is chapter 15, which talks about forecast methods. And we have started with that since the students who took MSc 3370 on week 7, we have covered simple linear regression. And under the forecast methods, you also gonna be finding uh, as one of them a regression analysis. And that's why we start with the forecasting analysis here to make more sense. Uh, if the students did take 3370 with me on chapter 7, you saw this kind of problems that we solved together. Just in case, if you did not take the class with me and if you're unsure on what I'm talking about when talking about simple linear regression, right here, how would you do that? For example, the height of notable tall buildings in America is compared to the number of stories of the building. So the way we're gonna solve this, we have your X, your Y inputs. So we're just gonna select this, go in insert, excuse me, and then did I go too fast? So let me go back. We're gonna go insert right here. We're gonna go in scatter. See where it says insert scatter, and we're gonna pick the first one right here. Okay, okay, these are all your points. This is your X right here, and this is your Y values right here. Okay, and then what are we gonna do? We're gonna click in one of these little points, and we're gonna add a trend line. We are gonna display the equation, excuse me, and the R square value on the chart. The line of best fit, where there is your slope, there is your intercept, and that's your R square, which R it would be your correlation coefficient, and R square is just the correlation coefficient square. That shows you the relationship right here when it asks whether uh, the correlation coefficient is significant. Right here we see about 89%, so we could definitely say yes. Okay, so the simple linear regression does falls under forecasting methods because it gives you an idea. It's based on historical data. Okay, so let's close this. So chapter 15, I'm sure that you have heard in your business before or someone else talking about forecasting or how HEB or how Target or how Walmart or all these big companies, big retailers, they use forecasting method to predict future um, sales, for example. Even if you're trying to predict sales based on a natural disaster, for example, uh, let's say that HEB wants to know which products they sell the most um, under a hurricane watch. They could use forecasting in order to do that because it's all based on historical data or data from the past, and then we consequently choose different methods, forecasting methods, to calculate this forecasting. And regardless of the method that you choose, whether it's an exponential smoothing or whether it is a naive method or whether it is under based on historical data, we always going to be looking at these three variables right here: the mean absolute error, the mean square error, and the mean absolute percentage error. As you can notice, they all relate to errors. Therefore, when you're forecasting, you want to make sure that these values right here, they're close to zero, right? So the closest to zero, the best, because it's less error. So that means more accuracy, correct? So it's always gonna error is gonna exist, but we need to make sure that we choose the best forecasting method to minimize the error. Okay, so the two that you really need to take close attention are these two, are the actually the mean absolute error and the mean square error, because the mean absolute percentage error is just a percentage that if you're not sure based on these two, then you would relate to the last one. Okay, and also if you're not sure, for example, whether we want to use an exponential smoothing or moving average, you look at these three variables right here to choose which one, and that's what we're going to be doing for chapter 15, problems 1, 2, 3, and 11. Right now I'm probably just going to be able to go over problem 1, 2, and 3. One thing that you must keep in mind, um, there's not one specific forecast error that we say, oh, this is the best one. It really depends what you're evaluating, what you take into consideration, what you're trying to achieve. So you could just, get a simple one, the naive, as it's called. The name itself tells you naive, so you go with that. Or maybe you wanna, maybe do a moving average. Maybe it would be better, or even an exponential smoothing. So again, uh, there's no reason to say my forecast method will be better than your forecasting method. It really depends on what you're trying to evaluate. So now that I have done the whole um, summary on the wording, let's go to the problems right here. Let's use the templates that I have provided to you. I just added a few things. Right here saying the using the naive method, the most recent value. Use the most recent period amount to forecast for the next period. Okay, compute the following measures: the mean absolute error, the mean square error, and the mean absolute percent error. And we also gonna forecast for week 7. I have put the formulas down here, which all they read right here. For example, the sum of the absolute value of errors divided by the number of values that we use. The mean square error is going to be the sum of the error square divided by the total of numbers, the total of weeks in this case. And then right here, mean absolute percent error, we're going to do the sum of the forecast error. We're going to do the sum of the forecast error divided by the actual data times 100%. But to do the mean absolute percentage error, you're going to average those by the total of weeks. And as confusing as all this sounds, here let's just start. Right here, week one. Well, if you're using the most recent period amount to forecast the next, right here, week one, we don't have the most recent, we don't have anything before that. Therefore, we cannot forecast anything for week one. That's why I just put it right here, this dash, like there's no forecasting for week one. Okay, so for the second one, it's going to be as simple as so using the most recent period amount for the to forecast the next period. So you're just gonna repeat on the 13 right here, you're gonna use the previous one. So all we can do is to do equals the previous one, which is 18, or you can just simply type 18. I like to use cells in Excel because once you change one amount, it adjusts everything else for you. If you type, you have to go back and check one by one. Okay, so if for week two, and they don't tell you really what these values are. So is they are just trying to show you how to really calculate um, these measures. For week three, we're gonna do week three is gonna be equals to week two, and then so far and so on. With Excel, as I have put it here, equals before boy 4, I could just go ahead and drag this down. But if you're not familiar with Excel and you make one error, everything else can go bad. I am gonna do it like this, and you can see that all it did, it just did for week two, you repeat week one. For week three, correct? For week three, you repeat it week two. For week four, you repeat it week three. For week five, you repeat it week four. For week six, you repeated week five. And right here it says forecast for week seven. So for week seven, if you possibly had week seven here, excuse me, repeating week six. So you can just continue here. Therefore, your forecasting for week seven would be 14. You can just type in here, or you can just do equals to this value right here. Okay. So now let's do your forecast error. I put it here C minus B to give you, actually I should put it over here. It really doesn't matter if you do C minus B or B minus C, because that's when we're gonna do the absolute error. The absolute error is gonna get rid of the negative value, because the negatives offset the positives. That's why we do the absolute error, okay? So if C, column C minus column B, right? So the forecast error is the forecast minus the actual data to see the difference. So we're gonna do equals. Again, I'm doing cells because I like to be more precise if we change one number. You could go ahead if you want to do 18 minus 13 if you feel better about it. That's fine with me. I am just doing the cells, so I'm going to do 18. I'm just equals. And if you another thing, if you're not in my 3370 class, to start a formula in Excel, you always have to do equals, an equal sign. So when you do equal, is already waiting for a cell or for a value. So equals my forecasted value minus my actual data, or they call it raw data. And then the same thing right here, you can do equals the forecasted value minus the actual value, the actual data. Well, another thing again, like I said, once you have put one formula, you can just drag it down and it gives you all the values. The problem with this is that, again, if you're not familiar with Excel and you have to always refer to one value, for example, and don't move that value, if you don't know how to do here, Excel will update as you move the values down. Okay, so if you feel more comfortable, go ahead and just type the values. Just do, or you can just do on your calculator, but you must show me your calculations. So if you go here and you put 18 minus 13, uh, you only see 5, but when I grade your homework, I'm going to be looking for the formula. And here's the formula. Okay, to make sure that you understood the problem. Well, the absolute error, if you remember, absolute means it makes everything positive to make sure the negatives offset the, because the negatives offset the positives, right? So we're gonna do equals to, I'm just again doing Excel, equals to the value. Actually, I'm wrong because Excel does have a formula for absolute right there. And now it's asking me for the number, which I click here, close the parenthesis. And if I drag it down now, it made the absolute for number 3, and then the absolute for number 5, the absolute for minus 6, and the absolute for 3. Okay, so now we're gonna do the square error. Um, okay, let me just look at something here. Well, like it says, square error. So you did the forecast error, you made it sure you put in an absolute form, and now you're going to square that value. What you can do, you can either do this cell times this cell, or you could do 5 times 5 if you're not familiar, or what you could do is to use 5 caret 2. That right here tells Excel is squaring this value. Okay, so enter. Here you go, 5 times 5, 25. So now we just drag it down. Oh, see, actually, I'm glad this happened. See how I put the number instead of referring to the cell? So it just literally repeated every single one. So what I need to do here to fix it, I need to refer to the cell. And now when I drag it down, it's gonna update the, see, 3 times 3, because now it's going by cells. E5, E6, if you look over here, E7, E8, E9. Okay. So now, so we're gonna do equals to the forecast error divided by the actual data times 100. Then I just drag it down. How did I get that? Then I'm gonna do this forecast error divided by the actual data times 100 right here. Then the forecast error divided by the actual data times 100. And now we're going to get the absolute value of this because you have negative values here. And again, the negatives outside the positives. So let's make sure that we do absolute for the percentage error. Let's just keep it at 2 digits. That should be more than enough. I'm just going to drag it down, and here we go. Why did I put these yellows here? You could just go ahead and average them over here, and then you would have all your um, answers. Okay, so instead of putting here, let me just go over here. In order to find the mean absolute error, the mean, the average absolute error, so I'm gonna need the sum of the absolute error because it says it wants the mean of the absolute error. So the sum of my absolute error divided by the total weeks, 1, 2, 3, 4, 5. So we're gonna do the sum of my absolute values, absolute error values, which if it confuses you, you can go ahead and do 5 plus 3 plus 5 plus 6 plus 3. That's fine with me as long as I can see it. All I need to do in Excel is equals the sum, open parentheses, and then I sum all these values and I divide it by how many weeks? 1, 2, 3, 4, 5. We forecasted for 5 weeks. We're gonna get a 4.4 measure, which is not close to zero, but we're still gonna compare to other values. Now we're gonna do the mean of the square errors. So like it says, we wanted the average of this column right here, right? Correct? So we did this and we did this. And then the last one, we're gonna do this one, correct? Okay, so let's go ahead and do the sum of these values right here divided by 5 weeks. Again, n is 5, is 20.8. And last, we're gonna do the sum of the errors, the absolute errors. That's why I had in absolute divided by the actual. So the sum of these values right here divided by 5, which is 31.88. So it would be done with problem 1. Now we're gonna go ahead and do that for problem 2. So actually should keep as the absolute because in the end, oops, in the end you are summing these values right here. Another way you can do the average of these values, and then if you can just carry it to the side right here to make sure. So 4.40, right, that's why I had put in yellow before. 20.80. Oh, you don't need this one, you really need the absolute one. And then 31.88, and then 14 for week 7 if you had a week 7. Now we're gonna go to problem number 2. Let's go back to your book, which I should have started by reading this problem. Consider the following time series data, and then it gives you the data, which I arrange it differently. So 6 weeks, correct? And 18, 13, 16, 11, 17, and 14. So 6 weeks, 18, 13, 16, 11, 17, 14. And I put in this format, okay? So then it tells you using the naive method, the most recent value as the forecast for the next week, compute the following measures of forecast accuracy. So we found the MAE, we found the MSE, we found the MAPE, and then we forecasted for week 7. And we will be done with problem 1. Now we're going to do problem 2. Now it says refer to the time series data in exercise 1. That means the same values you have in exercise 1 right here. Okay, and using the average of all the historical data as a forecast for the next period. Then you're going to compute this two again. How are you going to do that? First, make sure that you put all your information using the average of all the historical data as a forecast for the next period. Again, uh, there's no historical data before week 1, so we couldn't possibly do anything for week 1. Okay, so let's just go ahead and do like this. For week 2, we do have one historical data before, which is 18, correct? Well, but for week 3, we have all this two before, correct? So we're gonna do equals to, I can do the average of the 2 weeks before week 3, and it's gonna give me 15 points. So because if you go ahead and you do equals to 18 plus 13 divided by 2 is 15.5. That's what it's doing right here. Okay, now for week 4, what do you have? You have 3 weeks before that, correct? So what you could do is to tell Excel that you're always going to start you're going to lock 18. You're always going to start at 18 or before, cell before. And then now you want to go, if you go down, let me show you what happens. Okay, now we stop here, right? Let me go right here. See how I lock cell 4? So you understood that now for week 4, I want you at this cell, and this cell. If I go to the next one, since I locked this one, he added one more for me, column B, row 7. If I go to this one right here, and I locked before, I'm telling it, look, I want you to go from all the way to the top and include it all in average then. So he did for me before, column B, row 4, column B, row 5, column B, row 6, column B, row 7, column B, row 8, column B, and that was it, right? That was the last because it's the one before. Well, if I would do for week 7, as he asked right here, then I'm going to include B9, correct? So one more. And then my forecasting for week 7 is going to be 14.83. It did round. I don't want it to round. Or you could simply do equals to this value right here. You answer D. So now let's do the forecast error. Remember, the forecast error is always going to be the forecast minus the actual data, correct? Or the other way around it, because you're going to do the absolute. So equals to this value, 18 minus 13. And then I'm just going to copy, drag down, and give him these values. Now I'm going to make an absolute value of these values right here. So I'm doing absolute, the formula in Excel of this value, and I'm going to drag it down. Again, if you're not sure, comfortable with Excel, don't use this. Just go ahead and type a value, or if there's a calculation, make sure you do put the calculation there so I can see it. Now we're going to square the error. So we're going to do equals to this. And then I'm gonna do caret 2 to square, but you could do 5 times 5 or whatever works better for you. And I'm gonna drag it down. Okay, now we're gonna do the percentage. Remember, the percentage is gonna be your equals to your forecast error divided by your actual data, correct? Times 100. Okay, and then I'm gonna drag this down. Now I'm gonna do the absolute of these values. So I'm gonna do absolute this value. So they can all become positive. Here we go. So now I could go ahead and do the average of my absolute error, the average of my square error, the average of my percent error, which has to be equals here. So let's try that. The average of this values right here. And then I'm gonna drag to the side. So I should find these values over here. If I don't, it's incorrect. So I'm gonna do equals to the sum. So I'm looking for the average of these errors, the absolute errors. So the sum of these values divided by how many weeks? 5. and it's correct. So now we're going to do the average of the square error, right? So we're going to do equals to the sum of the square errors divided by 5 weeks. And if we put one more digit, there we go. And lastly, we're going to do the mean absolute percent error. So the sum equals the sum of the absolute error divided by 5 weeks. Here we go. And you have found all 4. The last question, question 3, is exercise 1 and 2 use different forecast methods. Which method appears to provide the more accurate forecast for the historical data? Well, that's why I added this here. The best way to do this, well, you could go ahead and just get these values and type over here. Another way to make sure you're correct, you can do equals and then refer to this cell right here. And then for the MSC, you can do equals, go back to this tab and select that cell and enter. And the last one, you do equals, click the tab, click this cell right here and enter. Okay. This format should be different. I don't know why it gave me, there we go. I hope it gives the same format over here. Okay. To do the problem 2, we can do equals to, click on the second one right here, click on this cell, enter, and then equals this right here, click on the cell, enter, and then equals the last one. If you go to each cell, you're gonna see how it's saying it took the value, it copied this value from the tab chapter 15 problem 1 right here from column B, cell 12. Column B, cell 12. That's all it's saying. And then the other ones as well. Okay, so now which one it seems to be better? Remember, we're looking for the more accurate, correct? So which ones here are closer to 0? In this case, with this data, these values here are close to 0. Therefore, it appears that the more accurate forecast for this historical data would be the average of all historical data. And we would be done with problem 1, 2, and 3. I do know it's a long video, but I needed to summarize chapters 1, 15, and give an idea about 16 and go over the problems. And if not today, I'm gonna try to tomorrow or latest Thursday to go over the 3-month moving average and the exponential smoothing. It's really not that difficult. It's just you gotta be very careful with the information that you're collecting, and then you can go ahead and complete the rest.